Hello, it's Mrs. Fike again, here to talk about the pH scale. In Unit 10, Objectives 8, 9, and 10 deal with the pH scale. In this video, we will be examining Objective number 8, the auto-ionization of water. We will calculate and define pH and pOH. We will define hydronium and hydroxide, but we will calculate the concentration of each of those at a later time. First, let's define the pH scale. It's a scale that ranges from 0 to 14 that tells us how acidic or basic something is. So 0 is the end of the scale where we see the most acidic substances. 14 is the other end of the scale where we see the most basic substances. And then 7 is neutral. This slide shows some common substances and their corresponding pHs. We can actually calculate pH and come up with an answer that ranges from 0 to 14, the pH scale. How we do that is by taking the negative log of the hydronium ion concentration. That's what this is right here. So this whole thing right here. Because we are using logarithms, the higher the hydronium ion concentration, the lower the pH will be, and the lower the hydronium ion concentration, the higher the pH will be. So why is pH based on the hydronium ion concentration? Well, it all has to do with the auto-ionization of water. Water doesn't just contain water molecules like we see here. Water also contains small quantities of hydronium and hydroxide, like we see here. So what happens with water molecules is one water molecule donates a hydrogen to another water molecule. So we're left with something that's missing a hydrogen and something that has gained a hydrogen. So hydroxide and hydronium. Water just does this automatically, all by itself, and so that's why it's called the auto-ionization or self-ionization of water. And the term ionization comes from the fact that ions are produced. Remember, ions have a charge, and you see those right here. When you add acids or bases to water, you are adding either hydronium or hydroxide. So for acidic solutions, we are adding hydronium. And so we'll see an increase in the concentration of hydronium, and then we'll see less hydroxide. For basic solutions, we're adding hydroxide, so we'll see an increase in the concentration of hydroxide and a decrease in the concentration of hydronium. So this is why we base the pH scale on the hydronium ion concentration. There is also a pOH scale, which is based on the hydroxide ion concentration, the other ion that is in water. This scale isn't used as commonly, but it is calculated the same way that pH is calculated, the negative log of, this time, the hydroxide ion concentration. The pOH scale also ranges from 0 to 14. However, the acidic end is now 14, and the basic end is now 0. This is the opposite of the pH scale, which you can see represented right here. So, if you have a solution and you know the pH, you can also figure out the pOH. The pH plus the pOH for a given solution always adds up to 14. So let's look at a couple of example problems. The concentration of hydronium in blood is 4.0 times 10 to the negative 8th molar. Now remember that capital letter M stands for molar, moles per liter. That's a unit for concentration, which is what we need to calculate pH. We'd like to know the pH of the blood and if blood is acidic, basic, or neutral. pH is the negative log of the hydronium ion concentration. So we will use our calculator to calculate the negative log of 4.0 times 10 to the negative 8th. You get an answer of 7.4 for the pH. So this is right around neutral, but slightly basic. In this next example problem, we have black coffee with a hydroxide ion concentration of 1.3 times 10 to the negative 9th molar. Again, those are units for concentration. We would like to know the pOH of coffee and if it's acidic, basic, or neutral. pOH is calculated by taking the negative log of the hydroxide ion concentration. So we're going to use our calculator and take the negative log of 1.3 times 10 to the negative 9th. We get a pOH of 8.9. Now remember, the pOH scale is the opposite of the pH scale. But if you ever get confused, you can always find the pH of a substance by subtracting from 14. This gives us a pH of 5.1, and you might be more comfortable with that, and you would know that a pH of 5.1 is acidic. So hopefully now you know how to calculate pH and pOH based on the hydronium and hydroxide ion concentrations and how that relates to the auto-ionization of water. Please now complete the Google Form video quiz. Thank you.